Good day, students! In this video, we're going to discuss remainder theorem, factor theorem, and rational root theorem. In previous lesson, we already discussed synthetic division. So let's try this. Divide p of x is equal to 2x cubed plus x plus 5 by x plus 1 using synthetic division. So for our solution, let's get the value of c, or our synthetic divisor. So from our divisor x plus 1, our synthetic divisor is negative 1. And to the right side of our synthetic divisor, let's write the coefficient of the dividend. So as you can see, from our dividend, there is a missing term, which is the x squared. So write 0 coefficient for the x squared. So therefore, our coefficients are 2, 0, 1, and 5. Let us now solve using synthetic division. First, bring down the first coefficient. Bring down 2. Then, multiply by the synthetic divisor. So, 2 times negative 1, that is negative 2. So, write the answer to the second row of the next column. Then add 0 plus negative 2, we have negative 2. And repeat the process. Negative 2 times negative 1, that is positive 2. Add 1 plus 2, that is 3. 3 times negative 1, that is negative 3. Add 5 plus negative 3, that is 2. So, from that coefficients in our third row, let's write our quotient. So, to write our quotient, just simply subtract 1 to the degree of our dividend. So, since we have x cubed as the degree of our dividend, so therefore our quotient is x squared. So, we have 2x squared minus 2x plus 3. And our remainder is 2. So, to write the remainder, so quotient plus remainder over the divisor. So, we have plus 2 over x plus 1. Let's try to solve the second question. Find the value of p of x when p of x is equal to 2x cubed plus x plus 5 and x is equal to negative 1. So, for our solution, just simply substitute negative 1 to the value of x. So, we have p of negative 1 is equal to 2 times negative 1 cubed plus negative 1 plus 5. Let's evaluate each term. Negative 1 raised to 3 is negative 1 times 2, that is negative 2. Then we have plus negative 1, just simply write negative 1 plus 5. Solve. Negative 2 minus 1 is negative 3 plus 5, that is positive 2. So, from the two different questions, what can you say about the result of two separate solutions? You will notice that when the polynomial was divided by x plus 1, the remainder is 2. And when the polynomial was evaluated by x is equal to negative 1, the result is 2. Therefore, you will notice that the remainder and the result as we evaluate the polynomial is the same, and that is proved using the remainder theorem. The remainder theorem states that if a polynomial p of x is divided by x minus c, then the remainder is p of c. So let's try the following example. Number 1. Find the remainder when x raised to 4 minus 3x raised to 3 plus 2x minus 1 is divided by x plus 2. So, for our solution number 1, let's use synthetic division. So, the value of our synthetic divisor is negative 2. And write the coefficient to the right side. So, again, put 0 for the missing term. So, therefore, our coefficients are 1, negative 3, 0, 2, and negative 1. And solve. Again, bring down the first coefficient. Bring down 1. Multiply. 1 times negative 2, that is negative 2. Add. Negative 3 plus negative 2 is negative 5. Multiply. Negative 5 times negative 2, we have positive 10. Add 0 plus 10 is 10. Multiply 10 times negative 2 is negative 20. Add 2 plus negative 20 is negative 18. Negative 18 times negative 2 is positive 36. And negative 1 plus 36 is positive 35. So therefore, our remainder is 35. Let's try the second solution. Use the remainder theorem. So for our remainder theorem, evaluate the polynomial using x is equal to negative 2. So our polynomial is x raised to 4 minus 3x cubed plus 2x minus 1. Substitute negative 2 to the value of x. So we have negative 2 raised to 4 minus 3 times negative 2 cubed plus 2 times negative 2 minus 1. Negative 2 raised to 4 is 16. Negative 3 times negative 2 cubed is positive 24. And 2 times negative 2 is negative 4 minus 1. So let's solve. 16 plus 24, that is 40. Negative 4 minus 1 is negative 5. And 40 minus 5 is 35. So we can see that the remainder are the same using synthetic and remainder theorem. So if the question is finding the remainder, you can use synthetic or remainder theorem. Let's have example number 2. Find the remainder when a raised to 20 minus 2a raised to 5 plus 8 is divided by a minus 1. So as you can see, the degree of polynomial is 20. So what is the best solution to solve the remainder of this polynomial? Okay, that is remainder theorem. Because we have long solution if we were going to use synthetic division, since the degree is 20. So for our solution, use the remainder theorem. The value of our a is positive 1. So evaluate the polynomial using a is equal to 1. So we have 1 raised to 20 minus 2 times 1 raised to 5 plus 8. 1 raised to 20 is 1. Negative 2 times 1 raised to 5 is negative 2 plus 8. 1 minus 2 is negative 1 plus 8, that is 7. So therefore, our remainder is 7. Next example, number 3. Find k so that when x cubed minus 2x squared plus kx minus 5 is divided by x minus 1, the remainder is 2. So this time, the remainder is given and we need to find the value of one of the coefficients of the polynomial. So for our solution, since the divisor is x minus 1 and the remainder is 2, then we can say that the value of x is positive 1 and that is equal to 2. So write the polynomial and substitute the value of x, which is 1. So we have 1 cubed minus 2 times 1 squared plus k times 1 minus 5. And that polynomial must be equal to the value of remainder, which is 2. So equal to 2. So 1 cubed is 1. Negative 2 times 1 squared is negative 2. K times 1 is k. Then minus 5 is equal to 2. Combine similar term. So we have negative 6 plus k is equal to 2. Use addition property of equality. So we have k is equal to 8. That is from 2 plus 6. Next, find the remainder when 2x cubed minus 4x plus 2 is divided by x minus 1. So for our solution, use the remainder theorem. The value of x is positive 1. So evaluate the polynomial and substitute 1 to the value of x. So we have 2 times 1 cubed minus 4 times 1 plus 2. 2 times 1 cubed is 2. Negative 4 times 1 is negative 4 plus 2. 2 minus 4 plus 2 is 0. So our remainder is 0. Since the remainder is 0, the question is the polynomial x minus 1 a factor of 2x cubed minus 4x plus 2? The answer is yes, and that will be proved using the factor theorem. The factor theorem states that if the polynomial p of x is equal to 0, then x minus c is a factor of p of x. And if x minus c is a factor of p of x, then p of c is equal to 0. So if your remainder is 0, then the polynomial x minus c is the factor of the polynomial p of x. So let's try to solve example number 5. Is x minus 3 a factor of x cubed plus 4x squared minus 15x minus 18? So again, to say that x minus 3 is a factor of the polynomial, the value of our p of c must be equal to 0. So for our solution number 1, we can use synthetic division. So the value of c is positive 3, and the coefficients are 1, 4, negative 15, and negative 18. Solve. We have 1, multiply, that is 3, add 7, multiply, 21, add positive 6, multiply, positive 18, add 0. So therefore, our remainder is 0. So we can say that x minus 3 is a factor of the polynomial. Let's try the other solution using factor theorem. So as evaluate the polynomial, the value of x is equal to 3. So substitute. So we have 3 cubed plus 4 times 3 squared minus 15 times 3 minus 18. 3 cubed is 27. 4 times 3 squared is 36. Negative 15 times 3 is negative 45 minus 18. Then we have 27 plus 36 is 63. Negative 45 minus 18 is negative 63. So 63 minus 63, and that is 0. So using factor theorem, we can say that p of 3 is equal to 0. Then x minus 3 is a factor of the polynomial. Let's have another example. Is x plus 3 a factor of x cubed minus 7x minus 6? So again, we can use different solution. It's up to you if you will use synthetic or the factor theorem. So let's use synthetic. The value of c is negative 3. And the coefficients are 1, 0, negative 7, negative 6. Solve. Bring down the first coefficient. Multiply. Add. Multiply. Add. Multiply. Add. So therefore, our remainder is negative 12. So since that is negative 12, therefore x plus 3 is not a factor of the polynomial. Let's use the second solution using factor theorem. So the value of x is negative 3. Evaluate the polynomial. So substitute negative 3 to the value of x. So we have negative 3 cubed minus 7 times negative 3 minus 6. Negative 3 cubed is negative 27. Negative 7 times negative 3 is positive 21 minus 6. Negative 27 plus 21 minus 6. So we have negative 33 plus 21. That is from negative 27 minus 6. Negative 33 plus 21, that is negative 12. So therefore, the value of p of negative 3 is not equal to 0. Then x plus 3 is not a factor. Next example. Find the value of a so that x minus 4 is a factor of 2x cubed minus ax squared minus 5x minus 12. So for our solution, if x minus 4 is a factor, then the remainder is 0. So it means that p of 4 is equal to 0. So substitute the value of x. So we have 2 times 4 cubed minus a times 4 squared minus 5 times 4 minus 12. And that polynomial must be equal to 0 since we can say that x minus 4 is a factor. Solve. So we have 2 times 4 raised to 3 is 128. Negative a times 4 squared is negative 16a. Negative 5 times 4 is negative 20. Minus 12 is equal to 0. So we have 128 minus 16a. Negative 20 minus 12 is negative 32. 128 minus 32 is 96. Minus 16a is equal to 0. Use addition property of equality. So we have 96 is equal to 16a. Use multiplication property of equality. Multiply both by the reciprocal of 16, that is 1 over 16. So we have a is equal to 6. Next, let's discuss the rational root theorem. Given a polynomial equation of the form with the integer coefficients and where n is a non-negative integer, the possible rational root of p of x are of the form p over q, where p is the set of all factors of a constant term and q is the set of all factors of the leading coefficients. So let's have example number 8. Determine all the possible rational roots of x cubed minus 3x squared minus 4x plus 12 is equal to 0. So for our solution, based on the theorem, to get the rational root, just simply get the factor of the constant term and the leading coefficient and get the ratio. So we have p over q. So our p is 12, so that is our constant term, and the leading coefficient, the value of q is 1. So the leading coefficient, that is the term with highest degree. So that is x cubed. And this is the constant term. So let's get the factors of the constant term. So both positive and negative. So the factors of 12 are 1, positive and negative 2, positive and negative 3, positive and negative 4, and positive and negative 6. And last, positive and negative 12. So the factors are 1 times 12, 2 times 6, 3 times 4, and vice versa. So we're just simply write the factors in order. And for the factors of the leading coefficient 1, that is only positive and negative 1. So evaluate or simplify. So the value of p of q. So first, we have 1 over 1, that is positive or negative 1. Then positive and negative 2 over positive and negative 1, that is positive and negative 2. Positive 3, positive and negative 3 over positive and negative 1, that is positive and negative 3. Positive negative 4 over positive and negative 1, that is positive and negative 4. Positive and negative 6, positive and negative over positive and negative 1, that is positive negative 6. And last, positive and negative 12 over positive and negative 1, that is positive and negative 12. So therefore, the possible rational roots are the following. The positive and negative values of 1, 2, 3, 4, 6, and 12. Let's have the last example. Determine all the possible rational roots of x squared plus 4x to the 5th minus 4x cubed plus 10 is equal to 0. So for our solution, let's write first the standard form of the polynomial. So we have 4x to the 5th minus 4x cubed plus x squared plus 10 is equal to 0. So we can easily identify the constant and the leading coefficient. So the value of p is 10, our constant term, and the value of q, the leading coefficient, is 4. So get the factors of p. So the factors of 10 are positive and negative 1, positive and negative 2, positive and negative 5, and positive and negative 10. And for the leading coefficient, the factors of 4 are positive and negative 1, positive and negative 2, and positive and negative 4. So to find the value of possible rational roots, simplify the value of p of q. So let's start with the denominator, positive and negative 1. So, evaluate natin lahat ng factors sa numerator. So, positive and negative 1 over positive and negative 1 is positive and negative 1. Positive and negative 2 over positive and negative 1, that is positive and negative 2. Positive and negative 5 over positive and negative 1, that is positive and negative 5. Positive and negative 10, positive and negative 1 is equal to positive and negative 10. So, we're done with the first factor of the leading coefficient. Now, the second one, which is positive and negative 2. So, simplify uli natin. Positive and negative 1 over positive and negative 2, that is positive and negative 1 half. Positive and negative 2 over positive and negative 2, that is positive and negative 1. So, that is already written. So, we don't need to rewrite it. Positive and negative 5 over positive and negative 2, that is positive and negative 5 halves. And positive and negative 10 over positive and negative 2, that is positive and negative 5. And that's already written also. Next, with our denominator positive and negative 4. So, simplify uli natin. So, we have positive and negative 1 over positive and negative 4. That is positive and negative 1/4. Positive and negative 2 over positive and negative 4. As we simplify, that is positive and negative 1/2. That is also written in our answer. Next, positive and negative 5 over positive and negative 4. That is positive and negative 5 over 4. And positive and negative 10 over positive and negative 4. That is positive and negative 5 halves. So, that is also written. So, therefore, here are all the possible rational roots of the polynomial. So, let's wrap up. The remainder. When a polynomial p of x is divided by a binomial d of x of the form x minus c can be solved using, so what are the two ways in solving the remainder? Okay, that is synthetic division or the remainder theorem. Next, x minus c is a factor of a polynomial p of x if the remainder when p of x is divided by x minus c is, what must be the remainder? Very good, that is 0. And last, the possible rational roots can be solved when the factors of the blank is divided by the factors of the blank. Okay, so the first one is the factors of the constant term divided by the factors of the leading coefficients. So that's all for this video.